Hello everyone. Today in this video tutorial I will be introducing to a new humidity and temperature sensor, that's HCPA-5V-U3. Now to gain more knowledge about this sensor, what we're gonna do is to roll upon the website, that is controleverything.com, and here let's search this sensor and let's see what we got it. It says that it's a humidity and temperature sensor plus minus 2% RH plus minus 0.3 degrees Celsius I2C Mini Module. It's a very high accuracy, as you can see. Precision is very good, and there are a lot more features as you can see on my screen. You can also purchase the sensor from here. I will be interfacing the humidity and temperature sensor HCPA-5V-U3 with a Raspberry Pi and a Python code, and to get the Python code I will be moving to the top resource tab, and here comes the Python code sample. You can download the Python code sample as a zip file from here, this very link. Also you can have the code from github.com, and the repository there is Control Everything Community. Now let's have a look over the hardware connections. We need to have a look over the setup. Let's have it. The first thing in the hardware setup we require is a Raspberry Pi, and these are the GPIO pins of the Raspberry Pi. Now what do we need is an I2C Shield. It's really important in making connections with other I2C devices and make the connection a lot easy. So we need this. Now gently place the I2C Shield over the GPIO pins of the Raspberry Pi and make a connection like this. Next important thing we need is our humidity and temperature sensor, that is HCPA-5V-U3. Now this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor. The next thing we require is a micro USB cable, just like this, and gently insert it over the power jack so that we can have a power supply, a power medium to power up our Raspberry Pi. The last thing we need is to make an internet connection, and there are two mediums. The first thing is an Ethernet or a LAN cable, commonly known, as you can see, and gently insert it over the Ethernet jack. Then we are done. If you don't have the first thing, then there is a second way out, that is the wireless nano USB adapter. As you can see, it might save your day also. Now you can also use for the internet connection. Now as we are done with all the relevant connections, now what do we require is to have a look over the code so that we can interface. Now for the interfacing part, first thing is to find out the Python code, and let's go to github.com for that, and here we have to search for the repository, that is Control Everything Community. And let's see, here we got it. And then proceeding further, we have the sensor, that is HCPA-5V-U3, and this is the Python code. But before proceeding, let's have a look over the instructions we need to follow and pursue. It says that we have to download and install SMBus library on the Raspberry Pi, and this link will help us to install the SMBus relevantly. Now note down all the dependencies, examples, commands which will help you to install carefully. Now note down, and this is the command to run the code. Note it down. Now get back to the Python code. As you can see, it's a .py extension file. Now notice carefully that in the code we have imported SMBus and time libraries, and we have the address of the sensor, that is 0x28. Then we are sending the start command 0x80, and it's a journal command, as you can see. And after that we are reading data of 4 bytes back from the sensor, and it's a journal read. As you can see, humidity and temperature data are there. Conversion of the data takes place here, which is according to the formalities we have to fulfill in the data sheet at HCPA-5V-U3. And at the very end, after so many calculations, we have to display the output data on the screen, which is the relative humidity in percentage RH along with the temperature in Celsius and Fahrenheit. It's the perfectly formatted for 2 places of floating point value. So this is a very generalized code, as you can see. Now let's see how it works and see the practicality of this code. Now for the purpose of going for the practicality, which is very interesting, what we have to do is to copy this entire code of the Python, as you can see on my screen, and open up the terminal for the Raspberry Pi connected via internet. And here what we're gonna do is to create a new file, as you can see on my screen, and here paste the entire code and then save it. Now this is the command, as you can see on my screen, and let's see what we got. We have the relative humidity in temperature, and let's see what we got. Now when I blow some air, over the sensor, you can see the changes in relative humidity and temperature in Celsius and Fahrenheit scales. So this is how the sensor works. Now what we're gonna do is to show the benefits, features, and specifically the applications regarding the sensor HCPA-5V-U3. HCPA-5V-U3 offers the most advanced and cost-effective humidity and temperature sensing solution for virtually any type of applications. Capacitive polymer sensor chip developed and fabricated in-house and CMOS integrated circuit with EEPROM are integrated into one embedded system in a reflow solder-able SFD package. These features make it very useful for a lot of applications such as energy saving, HVAC control, automobile and transportation, process control and instrumentations, and mass quantity application. This sensor can be purchased from this very site, that is controleverything.com, and you can have the code from the resource tab, and after that you can download the code as required. You can also have the code from github.com, and the repository there is Control Everything Community. In the end, I would just like to make it clear for any part, if there is any further query, you can reach us on controleverything.com and post your comments on the community page. For blogs and articles, you can have a look upon instructables.com. And to subscribe more video tutorials, you can have a look over our YouTube channel. I hope you enjoyed this video and have a good one yourself. Thanks a lot for watching.